Hi guys, at the beginning of this episode we're taking our field tests to a new system, Zeta Leporis, which is based on a real observed star only 70 light years from Earth. It's a very big and hot Class A star. They don't call them Class A for nothing. It's quite a complex system. That's the Class A star, and we've got a couple of other large stars around. And here's the gas giant. Well, you can see with the orbit lines, it's a veritable orrery of orbiting bodies. So here it is. I just want to show the orbit there. But yeah, it is a tiny moonlet orbiting super close to this moon around that giant gas planet that we just saw. So this maybe explains what we're about to see. This isn't the smallest moon in the elite galaxy, but it's not too far off. Moons have been found as small as 170 kilometers. This is about 2.5 times that. Better get back in the ship before we get too close. We're 60 kilometers up. Where are we? Look at that. Yeah, that's where we are. Well, let's have a little look around, eh? Head towards this weird mountain. Why would that be protruding in such a way? I very much doubt we're going to be able to land on this. So from a little higher up you could actually see a glow. I think you can see it from here. Faint glow on the horizon. Can you make that out? I think what that is the presence of an atmosphere. I want to bring up the statistics for this little moon. It is a rocky world. It is 2/10,000ths of an Earth mass. You can see it's just a tiny little potato. A radius of 406 kilometers, which is actually not as tiny as I maybe would have thought. The important thing is volcanism here. Silicate vapor and geysers. 96% rock, 3% metal, and tidally locked. So, that's the important thing. We've got volcanism, and I suspect that is what this structure behind us is. And what we can actually do is we can get to the height of the top of this thing, and then we can fly a straight line and find the height of the mountain. There's probably a way to triangulate it without doing this. So let's go ahead and fly 0 degrees. Whoops. Keep our altitude, and we'll fly until we come over flat ground. That is when we notice that our altitude isn't receding below us anymore. 5.1. I think it's going to be something like this. It's still going down. Okay, so 5.2. That's it. So that mountain is 5.2 kilometers tall. There you go, we've made landfall. Well, we should take a note of our position of landfall. I just had a little drive around, but for the records, we should get a reference. Okay, and we will take that as minus 35.6182 by 150.9378. Right, we're going to drive to 70 degrees past this mountain. Interesting shape on the side of it, like it was deformed. Sometimes that can happen with volcanism, right? You get like a swell. I remember Mount Hood has got one of those in Portland, where just, I guess, the lava had kind of pushed up under the cone. We've got this gorgeous downhill slope now and a really long plane. It's actually just bizarre driving the SRV here because there's so little gravity. Whoa! We're getting some pretty crazy air on the jumps. I think I'm going to call it New Mount Hood. No, I know. I'm going to call it Mount Timberline, because on the side of Mount Hood where they've got the bump, that's where Timberline Lodge is. That's how I always knew where to look. So because of that ridge on the side, this is going to be Mount Timberline. Wow, nighttime just happened really, really fast. That is crazy. Within a couple of minutes, it's gone completely dark. And that is completely bizarre to me. I mean, we're tidally locked to that moon right there. I guess what's happened, the reason it's so quick is we've moved behind that moon now. So you can see from the planet that the light would be hitting from the far side. And we're just, within a moment, completely dropped into darkness. Yeah, Mount Timberline that was a moment ago lit up is now completely in the dark. Just the lights of our headlamps. That is a fantastic transition. It's the kind of stuff that happens in a world like this. Well, it won't deter us in our expedition. We've got our own light. Have you ever driven on country roads at night really fast? That's what this feels like. Oh man. Except I keep bumping into stuff. Look at this. I had my low beams on. But that's the extreme mode. So often when you're flying, you turn around and see the large moon loom over the horizon, with one side or the other lit up by the distant star. I came to judge the hours of light at my location by its phases, like an Earth month accelerated and shown on a giant clock above me. That is our star there, a super bright A-class, and then you can see on the other side the main planet with the light on that edge. And that's why our shadow is directly underneath us right now. Midday. After leaving the vicinity of Camp Zeta, I set out across the moon in order to find more interesting features. It didn't take long. Moon A's surface is a dramatic contrast of canyons, mountain ranges, and flat plains in between. Measuring height was an important step towards my larger project of mapping planetary surfaces. As I've been investigating ways of capturing aerial imagery, the imperative to stay in straight and level flight is becoming increasingly clear. The altimeter seems like a valuable tool for a cartographer in Elite. However, it measures prominence, not any absolute height. I think this is the tallest peak. Latitude 45.71, longitude 2.7 degrees. And now let's measure the height by flying against the horizon out towards the plane, and we'll see what the difference in altitude is. But first of all, we need to make sure we're not any higher than the mountain. Whoops, that right there. Okay, so let's go. Wow, this is much bigger than Mount Timberline, which was 5.7 kilometers. Remember correctly, we're already up to 8.9 kilometers. Are we going to get past 10? Nope, 9.74 looks like is the height. Oh, so close to 10 kilometers. At 9,978 meters, it's a bit more than 10% higher than Mount Everest. I'm naming this Mount Skyline because this range I first found when the sunlight was on only half of it. Well, thanks for joining me today, guys. As cool as these mountains were, that wasn't the main reason I came to Zeta Leporis. There's another treat in store, and it's related to the yellow glow we saw on the horizon. So I hope I'll be able to show you that in an upcoming episode. This system has lots of beautiful and interesting features, and a lot of these are happening because of the moon's position in relation to the moon it orbits and then the massive gas giant close by. Anyway, I'll show you some of these next time, and until then, keep exploring.